Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to take a look at something that I get a lot of requests for, and something on which I've just sort of not really moved because it's very nebulous. It's a big thing, and I don't even promise that what we're going to look at today is the best version of what I'm trying to cover, because there's so many ways you could do this. But basically, what we're going to talk about is multi-tenancy in our JDBC code. Basically, the idea that we have a way of carving out our data and giving it different dimensions based on some distinctive attribute in the context of a given request, right? And that's vague. I know it's vague, but what it boils down to for a lot of people is when I make a request for this user, I want it to go to that database. When I make a request for another user, it should go to yet another database. So, you might be doing sharding, you might have a SaaS offering where you have things that are multi-tenant and they need to be on different physical databases. I mean, there's a lot of reasons why you might do something like this. I'll just leave it to your imagination to imagine, because there's just a countless number of use cases for this, and I get asked about it all the time. And it turns out that Spring has a really nice mechanism called the AbstractRoutingDataSource that you can use to build this. And it's meant to be built. It's meant to be something that you take advantage of. It's a pluggable template type that you can override, and it just does the job perfectly. So with that, let's get into today's episode. And as always, I hope you enjoy. Let's go ahead and get started. What we're going to do is we're going to build a new application that takes advantage of the abstract routing data source type in Spring Framework. We're going to also use Spring Security, and we're going to use some new stuff. So to take advantage of that, to better take advantage of all that, we're going to use Spring Boot 2.7 M2. We're going to call this, multi-tenant JDBC. That works. We don't need all that much. We need JDBC, we need the web support, and we need Spring Security. All right. Now, of course, this is all stuff that in the very near future will be workable in a Spring Native context, or rather in a Spring Framework 6 context. But at the moment, just for now, we're kind of in a limbo, right? Where this stuff probably will work in Spring Native, but I don't know, and I haven't really tested it. But it's going to be okay. It'll be okay. Like, it'll work, because I've done JDBC applications with Spring Native a million times over. So don't worry. Just by the time you watch this, we'll have Spring Framework 6 probably. We'll definitely have it. It's just we'll probably also have it by the time you watch this, given the long tail of videos. And at that point, along with Spring Boot 3, you'll easily be able to build Spring Native applications. Okay, so I want to use Spring Security, Spring Web, JDBC, and I guess that's it. Let's just go ahead and get started. I think the only thing we want to make sure of is Java 17. Hit generate. That goes into my my directory here, UAO multi-tenant JDBC. Going to open that up in the IDE. Okay, now obviously we wouldn't get very far putting together a video about connecting to multiple data sources, to multiple databases, without a database or two. So first things first, we got to solve that problem. So I have a little script here, right, called postgres.sh, and all it does is it takes as its first parameter the name of the database, and the second parameter is the port, and then it clears out any existing instances, which is probably not a great idea, but whatever. And then it starts it, right? So it gets a new instance. So we can actually use that. Let's go ahead and do that. We're gonna spin up two different instances, okay? So Josh env bin. Okay, here we are. Postgres, and we want to call this DS1 and 5432. Sorry, it's 4321. Actually, what is it? It's 5432 usually, right? So 5432. That's the default. We'll call it 5431 for the default one, for the first one, and then 5432 for the second one. Okay. So now we can confirm that that's working by saying pg password. Okay, Okay, equals PW. PSQL user is just user, and host is localhost. P is 5431, and the database is user. All right. So we've got our one table there, our one database instance. Great. What about 5432? We've got that as well, right? So here we go. We got our two different databases. Everything's fine. They're empty, of course. We're going to have to work on that. We need data. We need schema, but they're there. So we have two different instances running on localhost. Obviously, where they run is kind of immaterial. We don't really actually all that much care, but we need two instances. And now we're going to connect them. We're going to write an application that takes advantage of the abstract routing data source. Okay. First things first, we're going to create a type called customer. So the type customer has an ID and it has a name field. There you go. That's our entity. That's the basic structure of the object that we're going to use. And then from there, we want a web endpoint. That'll be the thing that we're trying to get to work at the end of this, right? If everything goes correctly, then this will be the thing that works correctly. Okay. Good. Get customers new handler function, and given a request, which is this bit right here, we'll have a server response, and the server response will have some data in it. So we'll say var results equals, and we're going to need a JDBC template to do this work. Obviously, I should probably extract this out into a separate service, but for now, let's just keep it simple. Query select all from customer even. Okay, and we're going to provide a new row mapper to map each result set back into a customer. All right, so there's this new customer, and we're going to say rs.get integer is ID. All right, rs.get string name. All right, very good. So there's our basic HTTP endpoint, and we just want to return that. So we'll say server response dot OK dot body results. Voila. There's our handler. Place it with a lambda. That's our endpoint. So if everything goes correctly, we'll have an abstract routing data source implementation that supplies the results from this query using one data source, but deferring to two different multi-tenant databases. Okay. Now we actually need to build this thing, don't we? So this is not all that hard. You have to override a key. This is a class with a template method, right? It's an abstract type called AbstractRoutingDataSource. So we're going to say class multi-tenant data source, and you can. I hope you will come up with something as a better name, right? Abstract routing data source. Good. And the required bit is the determine lookup key. Okay. So what we're going to do is we're going to trust Spring Security to give us an idea of who we are. And we'll use that to key into which database should provide the data for this request. But we don't have Spring Security installed just yet. We haven't actually done any of that yet. So let's just stub this out basically. So var authentication equals security context holder dot get context dot get authentication. All right, that's an authentication object, and we'll return something soon. The other thing that we're going to need to do is we want to make sure that this gets initialized after all the other data sources have been initialized. Okay. And so we just want to make sure that it's done so. So final atomic boolean initialized equals new atomic boolean. Good. And then want to override the determine target data source, right? So we'll say if this dot initialized dot compare and set false true, then this dot after property set. So we're basically, after this has been, when this is being created, we want to make sure we reinitialize, and we want to make sure this gets invoked at the right time. Okay, this will get invoked in the normal life cycle of this object, but we want to make sure that it gets invoked one more time at the very last second. The very first time we start to use this object, we want to make sure this thing gets invoked, because the data sources on which this thing depends may not be fully initialized at the time they're provided to this object, right? So the easiest way is just to make sure that we lazily defer that initialization that depends on the valid data sources to the last minute, right? That's what we're doing here. So we're creating a Boolean to check if it's been initialized, and if it hasn't, then to do that initialization. All right, so once we have our data source, we need to actually configure an instance of that. So we'll create a configuration class, data source configuration. It's just a configuration class. And we're going to be defining a bean of type data source. But as you can imagine, in this application, we're going to have more than one of those. So we're going to create a primary data source, multi-tenant data source. And from here, we're going to create an instance of our abstract routing data source implementation. So this part's easy, right? Var MDS equals new multi-tenant data source, MDS dot set target data sources, and we need a map of object to object. So the key is the tenant ID, and the object is the data source itself. The key, the tenant ID, is the thing that we're going to use to discriminate against all the possible data sources. To say this request is associated with this key, this tenant ID, and therefore it's associated with this data source, right? That has to be in common with our business logic and the abstract routing data source implementation. So let's go ahead and provide that. We'll say var map equals, and for now, let's just say new hash map, okay? We'll say object, great, map, and I think that's it. So we can just return MDS, okay? Now, we need to actually arrive at a list of all the other data sources. And so I'm just going to, I'll just do this the hard way. We're going to ask Spring to provide all the other data sources, right? And we'll process those. So let's say we're going to find only the data sources that have the prefix, that have a bean name that starts with DS, okay? So var prefix equals DS, okay? And var map equals data sources dot entry set dot stream dot filter e dot get key dot starts with prefix dot collect, right? So we're going to collect all that into a map. So collectors dot to, okay, collectors dot to map. And here, our job is to provide a way to discover from our entries the keys and the values of the resulting map. So given an entry E, we want a E is going to be the key substring. Let's see, the key here is what? The key is a string. So dot substring. Okay. And we want to make this object. Let's see here, object. And it'll be E. Actually, here, let's just do this the other way. The long way around, okay? So new function. Okay, and then the thing on the left is the key, and the thing that we want is actually, no, I'm sorry, this is all right, let's collect it. And we're going to collect it into a map. So to map. So we'll say E object E integer dot parse int e.getKey dot substring, and the prefix dot length. Okay, there's this. And from here, we want the values as well. So we'll say e object, and then we're going to say e.getValue. All right. So that'll give us a map of object of object. I've had to explicitly downcast them to that because, after all, we know that this thing right here is going to expect a map of object to object. Why not, object of data source? I don't know. Doesn't matter. But there we go. That's our thing, right? We've got our new map that has only the data sources that start with the prefix, which is DS. So that'll ignore our own data source and any other data sources that we may or may not want to be included. Okay. So there's our map. Now, for each one of those, we want to visit the data. Say for each map and entity. So that's tenant ID and then data source, right? For each one of those, we want to create an initializer to make sure that we read in the SQL. So new class path resource schema.SQL, so we can initialize it that way. Actually, we want an initializer. So new resource database populator. Okay, and then new class path resource. And we want this to be the tenant ID dash data, right? So we'll say tenant ID, and I guess we have a prefix here. So prefix plus tenant ID plus dash data.sql, right? Makes sense. That gets that, and this thing will actually initialize our database for us, right? So given the data source, it'll run schema.sql and it'll run whatever dash data.sql to make sure that our data source is correctly initialized, right? So we need to cast this back into a data source. Okay. Good. All right, and then I think that's it. I mean, we could print out, initialized. What did we initialize? We initialized tenant ID data source for voila. Right? Good. So there's our data source, our multi-tenant data source. There's our instances. That looks pretty good. I mean, obviously we kind of forgot something interesting here. We didn't forget, but we've deferred until later the discussion around how this is going to be actually resolved, right? And that's going to require Spring security, but we'll get to that in just a bit. At this point, we just need some data sources, right? This data source is going to be an aggregation, a proxy, a forward, a whatever, for a number of other different data sources. So I'm going to create a bean here called data source. It'll be called DS1, and we'll return something there in a second. Another data source here called DS2, right? Return another one there as well. And, we need something to actually provide these data sources. So let's just create a simple method here. You could, create your own configuration properties and so on, but I'm just going to hard code it so we can kind of see what's going on here. Var DSP equals new data source properties. Okay. And DSP dot set password PW. Don't do this, by the way. Don't write your username and password hard-coded in your Java code. It's just terrible practice. Set URL, JDBC PostgreSQL, localhost. We need a port, right? That's the distinguishing feature of each database. DSP dot initialize data source builder dot type, and the type will be a Hikari data source. Thank you. And we'll build it, right? So let's return that whole thing. So there we go. There's our instance. Now we can use that method, data source. This is 5432, and data source 5, 4, 3, 1. Okay, there we go. That should work. So now we have our data sources. Let's see, what is not compiling, I wonder. It's just the it's IntelliJ complaining that it couldn't figure out where this type is coming from. It's coming from the autoconfig. I wouldn't worry about that. And it thinks it needs to know about my SQL database, which it doesn't, because my SQL database is not here nor there. So ignore those, right? Otherwise, it's valid code. So let's go ahead and run it just to see if it any surprises. Oh, there's one. Let's see here. Failed alert. Oh, okay. The driver has to be on the compile class path, not just the runtime one. So did we add Postgres? Oh, I don't think I did I? So we'll go here and add one more thing. Copy and paste. It's not wrong if you just do it once. That's my rule. Okay, good. I mean, if you do the same copy and paste multiple times, well, not great. Okay, so let's see. What do we got here? Now it's looking for schema.sql. Obviously, that stuff doesn't exist. So source main resources, schema.sql, create, and you could parameterize this. You could have a different schema per SQL data store, but for the kind of multi-tenancy we're doing, we assume that every data store, every database instance has exactly the same structures, the same table, the same DDL. So create table, customer, ID, serial, primary key, name, varchar, 255 not null. All right, there we are. And we also want some data, right? So what do we got? We got data ds1.schema.sql, insert into customer, name values, Dave, Yushin, okay? And over here, we're gonna, wrong folder, put that up here. And then here, ds2.data.sql. I named that incorrectly. Jurgen. Okay. Let's see. This has to be renamed to data. Good. Now, this stuff, normally Spring Boot, when it would see schema.sql and data.sql, it would run that for us. But we don't want that because we're doing it kind of our own way, right? We have multiple data sources. It makes no sense. So make sure you choose never. In this case, it probably wouldn't have kicked in because we're using a remote data store, right? Instead of an embedded like H2 or whatever. But still, we want to make sure we don't have it running in the background. So keep that property specified. All right, now it's time to look at Spring Security. So we've got our application, our HTTP endpoint. We've got our data source configuration here. Let's look at security. Okay, so here we'll create another configuration class, security configuration. Okay. First thing we're going to do is, lock it down, right? Security filter chain. And here's why we're using Spring Boot 2.7. There's a new feature in Spring Security. There's a new sort of direction where it's now possible to create and configure everything by just defining beans as opposed to defining these template types, that have DSLs with them. I never understood the life cycle of those things. It was just, it always just, whenever I wanted to do something, it always just felt like I was getting, I was going to get the wrong result. I don't know. It was just me. But now there's a way to do everything you want to do just by defining beans. Okay, so you want to define the security filter, the security web filter chain. You can do that, right? So security filter chain, okay, and we just need to inject the HTTP security. We need to inject the HTTP security. So we'll say return HTTP. First we'll say HTTP basic with defaults dot authorize HTTP requests AE or whatever auth dot any request dot authenticated, and then from there we want CSRF disable, right? Just to make sure we don't get in trouble there. And we can return that. We say http.build. Good. So let's see what's wrong with this. HTTP basic. Oh, we need an exception. No big deal. Easy, easy, easy. Okay, so there's our security filter chain. That's for authorization. Now, we need to also configure authentication. And here we're going to plug in a custom user detail service. And you could probably use Spring Securities. Again, this is just a simple example. What we want is an integration with Spring Security that knows about the current tenant, okay? So that we can ask questions of Spring Security later on in our abstract routing data source. So let's say user detail service, okay, var UDS equals new, let's say user detail service, and we're going to say return username. Given a username, what are we going to do? Well, we're going to say, we want to get the current user. So we'll inject the users collection. So var users, we're going to come back to this in a second, but let's say it's a new hash map. Okay. And we'll have the string and the multi-tenant user. And this is a type that we need to create. So let's do that here as well. Extends user class user. Good. Okay, we'll get back to that in a second. But given that, we want to say users dot get or default, and we want to get the username. Get the key, get the value associated with our username, otherwise null. And if user should equal null, then we are required by the contract of the user detail service to throw a new exception. So that exception is username not found exception. Couldn't find, user. I like to yell in my exceptions, why not? And user. Okay, so there's the basic arrangement, but we need those users, so let's go ahead and create those. In order to make that work a little bit easier, I'll just create a little factory method here, private static user create user string username integer tenant ID. All right, so return new multi-tenant user, and we actually need to flesh this multi-tenant user out now. So we'll go down here, and our user has a constructor that we have to match. This is the one we want, but we want to add an extra field here, private final tenant ID integer. Okay, this dot tenant ID equals. All right, let's see here. Integer. All right, and we want a getter. Good. All right, there's our basic user type. So now we want to create instances of that. We can create a little convenience method here. User create user string name integer tenant ID. Did I already create that stub? I did. We don't need this one. We'll go down here. Return new user, new multi-tenant user. Okay, and it's going to be name, and then the password will just be PW because we know it will be. Is it enabled? Yes. Has it expired? No. So it's non-expired. True. Not expired. True. Not locked. True. And the tenant ID is this. Okay. This is the beauty of doing a demo where everything's like on my local machine and I don't have to ask questions or worry about it. But obviously, you should do something a little bit more nuanced if you have like different data stores coming from different places and all that. And then we can create our map here. Okay. So we're going to create some users here. We're going to say var rob create user, rwinch, he'll be 3, 4, so 5, 4, 3, 1. And then there's me. And okay, and that's J long, 5, 4, 3, 2. Okay. And we're going to just put those in our collection here, don't we? So we're going to say stream.of Josh Rob dot collect, and I want to collect this also to a map, and the key will just be the username. So get username, and the value, will be self, basically. Okay. So there's our collection of users, and when somebody tries to get a user, it'll consult that map. If it's there, great. If it's not, it'll return null and throw an exception. All right. So we've got our users. We've got our user detail service. We've got our create user static helper method. We've got our multi-tenant user type. That is, where is that thing? We've got an implementation here. Okay. So here we go. What is this going to do now? Well, we're going to say if authentication does not equal null, authentication.getPrincipal, instance of multi-tenant user like this, then we can just downcast using a nice feature in modern Java, smart casts from Kotlin, for example. We get the user tenant ID, and then system out, the tenant ID is okay, and we can return the tenant ID. So that'll be used to distinguish which data source should be used for a particular request. It's going to consult the currently authenticated user, the one that's in the security context, which is a sort of thread local, but with extra benefits that Spring Security maintains, that contains the context, the user associated with the current ongoing request. And obviously, the request might span different threads. Spring Security manages propagating that for you. If you had built your own abstract routing data source and it had been tied to some thread local, then you would be in trouble if you had to deal with, for example, asynchronous requests in the context of, for example, Spring MVC's service and event support or future support or whatever. So in this case, we have something, we get an extra benefit for free, which is we don't need to worry about propagating our application's security context from one thread to another. That should, fingers crossed, get done for you when you're using Spring Security. Okay, looks like we've got everything we need. We've got the multi-tenant data source. We've got our customer type. We've got our multi-tenant user. We've got our user detail service, our supply chain, our filter chain rather. We've got our filter chain. We've got our data sources. We've got our multi-tenant data source implementation, which we've marked primary so that Spring, when it reaches for a data source, it knows which of the three it'll find that it should use. And then we've got our HTTP endpoint. Let's go ahead and run this and see what we get. Oh, we need to provide this. There we go. Let's see, count non-locked, new, we can just say list.of, new simple granted authority, user. Pretty. Okay, looks good. Let's try it out, simple as that. So curl u jlong pw HTTP localhost 8080/customers. Okay, I got something wrong. Who knows what? No password encoder. We need to make sure that the password that we store for each of our multi-tenant users is actually encoded, right? And I didn't do that here. Okay, so what is the password? The password is here. And, to keep it simple, we'll just password encoder factories dot create delegating password encoder dot encode password. Let's try this again. Customer already exists. Okay, fair enough. So create table if not exists. All right, now, what about this? Customer still unhappy. Lookup key is 54321. No. I want the keys to be based on the name of the data source. The keys are supposed to be based on the names of the data sources. I used the ports. Mea culpa. I don't know what got over me. Okay, take 2. Voila, there's the data in that database. And what about that's for JLong. That's for JLong. Let's try our winch, and he should get a different set of data, and indeed he does. Very cool. So if we log in, PSQL, PG password equals PW PSQL user JLong localhost P5431 user. Nope, that's not it. It's user, isn't it? That's the username, is just user. So, okay, select all from customer. Okay, there we go. There's same data, so let's delete from customer. And what about the other one? 5432. Delete from customer. Okay, let's restart. Make sure we have everything we need in the right place. Okay, there's 2 there, Jürgen and Olga. And what about this one? Select all from customer. There we go, Dave and Yushin. So with that, my friends, we've looked at how to use the abstract routing data source to very easily, dynamically decide to which data source a particular request should go. And I used Spring Security here because it has a very convenient scoped mechanism that we can use, the security context holder. But again, anything would work. If you would decide it's some information in some user's account or something in the body of the request, whatever, as long as you can put it in a place where that data source can then consult it. So that usually involves a static variable and some thread local or something like that. But either way, very, very powerful. So there's a lot of different use cases for multi-tenant sort of this style of data source where you're delegating to an algorithm to decide to which data source a particular request should be bound. But hopefully you can see the possibilities. And as always, I want to thank you for watching, and we'll see you next time.